Okay, so hello everyone. This is a little presentation on Machinekit, MPC, and FreeCAD Path. I'm going to talk a little bit about some of my personal background, the path to the MPCNC project, the actual build project itself, and touch a little bit on FreeCAD Path. Well, I am a degreed mechanical engineer. I work for I'm working as an industrial engineer for an aerospace gear company, and one of the things I like to do a lot is custom application development in ERP database applications. As far as associations and interests, I'm a member of Workshop 88, which is a makerspace in Glen Ellen, Illinois. I'm also on the board of directors of Fox Valley ASME. And as far as things that I like, I tend to be a jack of all trades, master of none. Current interests are 3D printing. I love machine tools. I'm a home shop machinist. I'm getting into CNC. I've played around a lot with Arduino, BeagleBone, Linux, programming. Current interests are FreeCAD and Machinekit, and I'm also into beekeeping, although the bees did not make it through the winter this year, and no bees this year. So my current projects include Machinekit projects include a Zieg CNC mill using a Gecko 540 with a BeagleBone and Machinekit. This is a Workshop 88 club project. Also, a project that's been ongoing is something I call my Wedgie, which is a Delta style printer, which is using some technology that I've been trying to work on, which is these maker printed linear bearings. And also the Maker MPCNC project as well. This is actually a picture of the Workshop 88 Zieg mill at Workshop 88. And this is the actual controller inside. And let's see if I can, oh, where's my mouse? There it is. We have a BeagleBone black, and we had a cape which was called the Rosetta Bone Gecko, which unfortunately is not in production anymore, which has a parallel port interface that goes directly into the Gecko board. Works very nicely. We're currently hooking up to the with a HDMI monitor, keyboard, although I'm looking at some of Frederick's presentation. That's some cool stuff he did. I think we're going to have to start looking at doing something like that. So one of the things that this all started out with, as far as this MPCNC project, comes back to my Rockbot. This was a little 3D printer of my own design, and I call it a Rockbot because it's actually mounted on a piece of marble tile that I got from not Home Depot. Why can I think of their name at this point? But Lowe's, actually. And actually, Lowe's has it on clearance at this moment. They're clearing these tiles out for about $2 a tile. What was really interesting about this was I had laid these tiles down on my surface plate at home, and I was getting stiction on it. And I thought, for the cost, that was just crazy that I was getting some really good flatness for a really cheap price. So on this particular design, I basically had angle iron that I bolted straight to the table, machined some holes into the angle iron, and I got a really nice system, really rigid. Used some diamond core drills. That was getting a little fancy here to put the vertical posts in there. Been really pleased with that, but once you start getting into a 3D printer, what's the first thing you want to do when you have a 3D printer? You want to make more 3D printers using your 3D printer. So that's one of the things that happened was at our Workshop 88, we bought a Kossel Clear 3D printer, which was basically laser cut acrylic plastic using standard forms. And I started looking at that, and I was like, oh, wow, this is really cool. I can do something like that. So one of the things that happened was I started on this work on the Wedgie, which is kind of a ongoing project. This is inspired by the Kossel Clear, and it actually has, it's all based on a wedge components, and the parts all bolt together. They you tighten the wedge, and it all forms all properly. One of the things that I didn't like about the Kossel Clear, well, I really liked the bearing arrangement that they had on the Kossel Clear, that it's riding on the diagonals of the Misumi extruded rod, and I thought that was particularly clever. But what I didn't like was the fact that the entire setup was a bit wobbly. So I thought, well, okay, you know, I want to see if I can improve on that. So I started down this path of wanting to design my own linear bearing. Well, you know, one of my motivations on doing these build projects is I like to have a deadline that I can bring to for a STEM event or a maker fair, and have these things as you know, a nice deadline to get a project done. And you think making a 3D printed linear bearing would be sort of easy. Well, I got up to about revision K before I had any kind of success, and trying to get a pure developmental project done by a hard deadline was proving to be a little bit problematic. So this is one of my first successes, and now I started doing some other my L series, which is kind of fun. So to get some things done for, well, okay, so we can get to why I built MPCNC. I wanted something low cost that was experimental, that I could use for you know, learning about Machinekit and FreeCad Path. It also kind of fulfilled my personal itch to use my Rockbot to build another machine, which is kind of, I don't know, maybe that's more of a Dave Gingery high-tech version of, you know, build your own metalworking machine shop from scratch, except I'm using 3D printing now. And I wanted something that would basically show well at Maker Faire and STEM events, and would be relatively quick to build. And also, you know, I just thought it was cool. So here's me at the, I think this was last year, at the Northside Mini Maker Faire in Chicago with my MPCNC. And you can see it's basically a dual gantry design, and it's made from 3D printed components, 606 skateboard bearings, bolts, Emt Pipe, the HTD belts. If you go to the MPCNC website, there's all kinds of people doing all kinds of interesting things with this. People are using it for CNC routing, which was my primary interest. Also, there's people using it for 3D printing, vinyl cutting. I've seen some people using it for laser cutters. The main thing, though, is the stock MPCNC controller is basically using a ramps board, some modified Marlin. So I was more, since I did a little bit of a different path, since I was interested in using this as a system where I could get better experience with Machinekit. Well, as far as, I think one question people would be asking is, how much do one of these things cost? I actually was in a little bit of a hurry, and I also, not only being in a hurry, but I also wanted to support the developer. I wound up buying a parts bundle from the guy. You can also, if you don't have a 3D printer, you can buy a printed parts bundle. So I think somewhere I'm into it somewhere around, let's call it between $400 and $500 so far. I'm using a DeWalt DW660 router, and I had my own power supply. So as far as building one of these, you have to buy yourself some pipe, get yourself some 3D printing, and that kind of starts the project out. One of the things that here are the printed components that have been assembled already. One modification that I did was that instead of using the printed motor supports, I wound up remodeling those supports and cutting them out on our laser printer at Workshop 88. A lot of these designs right now have been changed around quite a bit. The project has been evolving quite nicely. One thing, if you happen to want to build one of these yourself, this was something that I kind of learned the hard way, is that you probably want to run a drill or reamer through your holes, because if you bolt to a 3D printed part that's a little bit smaller than if your bore is smaller than your shoulder diameter, you can get some cracking, and that's one of the things that I was experiencing here. Just a little side note, the maker MPCNC uses PLA as opposed to ABS. PLA has a little bit more rigidity, and I guess there's a lot of size issues with ABS, so PLA is recommended. Actually, PLA is quite repairable too. You can grab yourself a soldering iron and you can just weld that right up and repair it. So that wasn't really a problem. Just a couple things that I did was I had little calibration sticks that I cut. Cut two pieces of wood at the same time, and I cut some notches in there as well, and that got my set my squareness and made sure I had nice little parallelograms. And well, the system itself, the build system itself, lends itself to being quite square. Here's what I did to set the height. Basically just a 6-inch veneer. And one of the big problems that I was having here, you can see here, I actually cut out a couple notches in the wood, and when I went to the other side, I was having problems with the carriage. This was a first-generation carriage, and some of the, well, you can see here, the basic problem with the carriage is there's all kinds of, there's too many 3D printed components printed together, bolted together, and there's just huge stack-up issues and not really a good way of making adjustments. So that was actually a major annoyance for me. Fortunately, the next generation, which I actually have printed out on my desk right now, I just haven't gotten a chance to put it together, is a much more simplified design. And I think as far as these squareness issues, that should be much better in the next design. I just have to put it together. For a controller, I'm actually using a BeagleBone Black with Charles Steinkühler's Cramps board. It's worked out quite nice. I got aircraft connectors on there for hooking up. I use a external power supply, which comes in kind of handy because if I want to work on it, I don't have to lug around a big controller. It comes apart quite nicely. It's quite portable. And right now where it's at, this is still a work in progress. I'm using Gantrykins, which has its own limitations. There's no auto homing, which is something that I would like. We have that set up in our mill at Workshop 88, and it's just really, really nice. Also, using Gantrykins, it's kind of a little bit of a pain because you have to be switching over from joint mode to world mode quite a bit, and it's a little bit awkward. Currently, the system doesn't have any homing limit switches. That's part of the next step that I have to do. Another issue that I'm having with this particular design is that the There's huge scaling issues between the X and the Y and the Z motor. There's a 5/16, what would that be, 18 or 20, I forget exactly, threads per inch on the Z axis, which is, I think, a little bit too fine. And what happens is when you try doing rapid moves, the motor's just screaming, and I'm losing steps. So, and it's just something that I need to work on there. So basically, some of my to-dos on this project still are to add homing and limit switches, switch from Gantrykins and to trivial kinematics, and I want to use Charles's robotics dual motor homing solution. And as I said, I want to update the carriage, which hopefully will get things worked out quite a bit. Now, one of the things that I've been doing is, I've been wanting to use a full open source toolpath from generating G-code to a machine tool controller. And one of the projects that I've been working with is FreeCAD. All the modeling that I did for my Wedgie, actually design work for the Rockbot, were done in FreeCAD. And right now, one of the things that's been under very, very active development has been the Freecad Path project. There's a few things you need to know at this point with Freecad Path if you want to use it. As I said, there's been a huge amount of code development. And if you go to Ubuntu and try loading up FreeCAD out of the standard repository, I think you're at level 0.15. And I'm not even sure if Path is in that. And if you go to the stable build right now, you have to go to, you get 0.16, and Path is already severely outdated in that. I think there's like 1,000 commits behind or something like that. You really need to go to 0.17, which is the daily build. Path, from what I've seen, it's very usable. There's not that much of a learning curve to it. The thing is right now, something that's somewhat unprecedented in the FreeCAD project is that there's a lot of workbenches being worked on simultaneously, which is historically, I think they used to focus more on one particular workbench and move on. Right now, there's a lot of activity going all over the place in the FreeCAD. So some things you need to know about 0.17. As I said, there's major revisions going on in FreeCAD. I tried opening up and doing some basic drafting, and in solid modeling in 0.17, and it's a little crazy right now. There's a lot of new features in FreeCAD, good features, that if you're going to be wanting to use FreeCAD and Path, you're probably better off, at least for this point, to use 0.16 and 0.17 side by side. 0.16 is good for drawing and modeling. I mean, you could do it in 0.17, but like I said, there's a lot of new features and functionality. If you have drawings, or at this point, you might want to just stick with 0.16. 0.17 definitely is the way to go for Path. As far as when 0.17 is going to be released, that's kind of like a little inside joke in FreeCAD. The adage is, it's done when it's done. Current guesstimates is that it's going to be 6 to 12 months away before they do a 0.17 is in release mode, but hopefully that'll come along. It's definitely worth, I can say that Path is worth playing around with if you're interested in doing it. So one of the things that I was experimenting with was I needed to make a little motor bracket for my Wedgie. So here's the actual model, and you can bring it into Path, and it's fairly straightforward. I mean, there's pocketing, drilling operations, profiling, I've also seen some things for some plugins for vinyl cutting, adaptive controls. Just, it's a nice little package. It's only going to get better. Here's, I don't know if you can see that or not, that's actually bringing it into Linux CNC. There's a bunch of post processors available for, there's a fully functional processor for Linux CNC. Machinekit works fine. So why FreeCAD Path? Right now it's built on a very solid, well-established CAD package. It's scalable. It's very customizable with Python if you want to do some custom applications. As I can say, it's getting nice, and it will continue to get better. As far as learning resources for FreeCAD Path, right now, you know, I'm the best person to talk to is Brad Collette, aka also known as Sliptonic, U channel. It's supposed to say YouTube channel. Oops. And also the FreeCAD forum. Right now, there's Brad is probably the leader of the FreeCAD Path project. He also, there's Daniel Falk, who is also working on it, Marcus, and Yorick, who are also some developers on the FreeCAD Path project. They're working on it also. Good guys. This is just, like I said, it's worth taking a look at it. It is a very, very nice project. Oh, that's pretty much it. So yeah. So that's my presentation. Any questions or anything like that? No.
How do you like the overall mechanics of the conduit? Is it nice, stable? What kind of stuff can you cut with it? Would you recommend it to somebody?
I would recommend it. I'm hoping that a lot of the debacking problems will go away with that enhanced carriage design. Right now, I've done some V-carving, using Gecko tools in Inkscape, which does a nice little job of that for wood. I haven't really played around with it with aluminum. I'd say, you know, definitely not steel. That's not going to happen with steel. There's, you know, that has a similar belt design as what the Shapeoko 2 has, which, you know, for what it is, it's a nice little system.
Yeah, it's really limited. This is drastically larger than the Shapeoko, and
oh yeah, it has a little bit of a larger build volume of the Shapeoko. Plus, what's really interesting is it's a very, very flexible design. You can expand the build volume out quite a bit. You can actually put supports underneath it to get a longer stride. That particular, well, hang on, let me see if I can. Get back to.
I think it's about the same cost roughly as the Shapeoko 2. Isn't it on the same order?
It's on the same order, but once again, like I said, if you can scrounge, I mean, you can really get the cost down on something like that if you're on a limited budget. And really all you need is access to a 3D printer. So that's what makes it very, very appealing to me. I think it's a great project for people interested in getting into CNC for the first time. As I said, you can turn it into a vinyl cutter if you want. I mean, for me, I think this is a great opportunity if you're interested in learning about CAM. And you want to, and you're a tinkerer, you want to build something yourself that you don't necessarily want to design. plans are freely available on FreeCAD, on Thingiverse to download. For me, what is really intriguing now is you've gotten to the point where you can use a full open source tool chain from Machinekit as a CNC controller to Freecad Path for G-code generation, FreeCAD to the generating CAM or generating models. It's a very, very interesting time. So for me, that's that's something that I've really found interesting and rewarding in this project. Sure.
Are you also using FreeCAD for the CAD for designing parts?
Yes, FreeCAD is my primary tool, and one thing is well, actually we can hang on one second. Let me find something here. I pretty much use FreeCAD all the time, and I've been using 0.16, and I've enjoyed it. And I started using 0.17 for Path, and I tried doing some modeling. And FreeCAD 0.17 is a major change to, I think I have a link here somewhere. One second. Uh-oh. As I'm jumping around here. Where'd it go? If you go to the, I thought I had included a link in the presentation, but 0.17 for modeling is just much different. They have bodies now, which is a different construct, and it's very much in active development. There's not a lot of documentation on there. If you're used to using earlier versions of FreeCAD and you try doing some modeling right now, it is totally different. But I think it's going to be better in the future. Part of the limitations of FreeCAD originally was that if you wanted to map to a face and then do some pocketing or other things, you were limited to that face. And in the tool chain, one of the things that was happening is if you did a change earlier in that model, it would tend to break the face, and you'd have to relink and do all kinds of things. And this is specifically one of the things that they're getting around in 0.17. But I actually there's not a lot of documentation at this point on those particular features in modeling. So it's a bit of a learning curve right now. I think hopefully within the next 6 months, as people start using it more, as there's more YouTube videos on there, it'll start getting a little more traction. One of the things they did with that 0.7 with these bodies is they want to lay the foundations for better assemblies. That's one thing that FreeCAD doesn't do particularly well right now. It's a powerful tool for modeling individual components, but as far as placement of assemblies, that's fairly weak, and that's something that it's going to be a major improvement, but it is a big shift in the design. So if for me, it was like I thought I was really hot stuff using FreeCAD, and then I go to the new 0.17, and you're like, what is going on here? So, hopefully within the next 6 months or so, there'll be a lot more documentation on how to use the new drafting features, and also some of the features in part design, and that will stabilize. So it's a little, as far as 0.17, it's a little rough right now. But as far as basic drafting, I'd say stick with 0.16, and it's a lot of fun. You can do a lot of nice things. Like all my MPCNC or my linear bearing project, the Wedgie, my Rockbot, that was all modeled in FreeCAD. So it is a very powerful tool, and it's free, and great community, very nice. A lot of people doing it for the love of it. So it's a good project. All right, well, thank you very much. All right, how do I end here? Yes.
Down at the bottom, there's a stop sharing button.
What's that? Down here?
Yep. Switch to Chrome.
Like, wait. Oh. Chrome and stop.